In the last video, we introduced RapidMiner Studio and demonstrate how to build a decision tree machine learning process on RapidMiner Studio. In this video, we shall demonstrate RapidMiner Auto ML. RapidMiner Auto ML enable people with limited machine learning expertise to train high-quality models specific to their business needs. The Auto ML will evaluate your data, provides relevant models for the solution of your problem, and helps you to compare the results of these models once the calculations are completed. To get started, choose the Auto ML model view by pressing the button at the top of the RapidMiner Studio. After starting the Auto ML model, the first step is to select the data set from one of your laboratory. Let me select the same one as my previous video. Having selected a data set, you have to decide what kind of problems that you want to solve. Auto ML identifies 3 different tasks. Predict, if you want to predict the value of a column. Cluster, if you want to identify groups in your data. Outliers, if you want to detect outliers in your data. Within the prediction category, you can solve either classification or regression problem. So let's choose predict and click on the data of the column that you want to predict. Then choose next. You will see that this future customer have 2 values, yes and no. So this is the problem of the classification. In general, for classification problems, Auto ML will display a bar chart with the number of data points in each class. When there are more than 10 classes, only the 10 classes with the most data points are displayed. Click next. To select your input. Not all the data columns will help you to make a prediction. By discarding some of the data columns, you may speed up your model or improve its performance. But how do you going to make that decision? A key point is looking at the patterns of the data. For example, columns that are too closely mirror the target column, and that this is a correlation problem. Or columns that have nearly all the values that are different, or columns that where all the values are identical, or columns with missing values. So these columns, you might want to consider to discard them for model training. An Auto ML model will summarize the situation with a color-coded status bubble: red, yellow, green. If it's green, that means it's all good to go. So we will select all the columns and click next. Next is the model types. Auto ML model will provide you a selection of the models that are relevant to your problem. If there's no time constraint, the best option is to build all of them and compare their performance once they are finished. So let's click Run. Depending on your data set and the models you selected, you have to wait for the results. You can stop the model building at any time by pressing the stop button. Intermediate results are displayed once they are available. You can look at different results, for example the overview, to compare the model accuracy or classification errors, or AUC, or precision or recall. So let's choose accuracy. So here is the comparison of the accuracy and the runtime, classification error, AUC, precision, recall, F measure, sensitivity, and specificity. You can also look at the ROC comparison to see which one will give you the best ROC. So we still have 3 more models to complete. So based on whatever that is available here, let's look at the accuracy. And let's sort the accuracy. And you can see that deep learning has the highest accuracy, followed by generalized linear model. And if you look at the runtime, random forest has the highest runtime. So you would like to balance between accuracy and runtime, so that you have a high accuracy and low runtime. If we look at the AUC and sort the AUC. For AUC, logistic regression, random forest, and generalized linear model, gradient boost trees, and support vector machine all give a AUC of 1. But we would not like to choose random forest because of the high runtime. And we might also don't want to consider the gradient boost because of the high runtime. So in this case, given that the support vector machine have a 97% and a relatively low runtime, we might want to consider the support vector machine for this problem. This concludes the tutorial on a quick rundown on the RapidMiner Auto ML. If you like the video, please feel free to comment, share, and subscribe to our channel. Thank you.